Library. Whenever you're ready. Rastafari. That's it. Whenever you're ready, I'm ready. We ready? Yeah, bless. Yeah. Coming in live shortly. Yes, we do give thanks for life in the mighty life, we want to give thanks for all good things around us and from Zion above. So we praise God for his divine love. We do give thanks for this wonderful day, this beautiful day. We give thanks as we are live with you on Helen Television System, that is HTS, in St. Lucia. That's one of our live programs, and also we are live streaming on YouTube and on Instagram. So all those people who are live with us on Instagram, Kio, Blessed Love, Honorable, Teachers is 758, give thanks, Honorable Blessed Love. All those of you on YouTube, definitely we do give thanks to be in your divine presence, as definitely we give thanks for all those people who are in St. Lucia, also watching us live on television, on Helen Television Service right here in St. Lucia. We give thanks definitely for this divine opportunity, as we are thankful for just being with you, and we are thankful for ever having that opportunity to be in the capacity whereby we can actually be sharing knowledge. And it is very important that we share knowledge, because how the system has been divided, has been devised, right? The whole vice of the system is basically to allow us to believe that there are simple little things, tiny little things, minute little things that are supposed to actually keep us separated. But as just as the physical structure is is a combination of a wide variety of very different, completely different types of cells and tissues and organs that actually come together to make the whole, that actually the physical structure, your physical structure could actually function as a unit, as a one, right? So when we look at the whole vibes, when it comes to the whole aspect of anatomy, when we study the human anatomy, and then you study histology, histology basically is the study of cells. So this would mean that you are studying the microscopic nature of cells. What do a cell look like microscopically? What is a microscope? Micro means that it is extremely small. You're talking about nanometers that you have. It's a microscope. So you need, it's micro, it's going to be scoping some tiny, tiny, tiny nanometers size objects. And it's going to make you see, you're going to scope it. You scope that over there. Yes, I scope it. So you microscope, you have telescope, and all these things, their scope just basically allowing you to see. But when it comes to the whole aspect of the histology, histology is a study of cells, and anatomy is the study of that whole organism, that whole physical structure, not in the nitty-gritty aspects of the whole realms of the cells that make up your heart, but it just tells you about the heart as an organ. But the heart has plenty different types of cells that make it. You have different types of tissue. You have connective tissue, you have cardiac tissue, the cardiac muscle cells, and still you have epithelial cells, right? You have plenty different kind of cells that actually make up the heart. You have neurons, right, that make up the heart. So the heart has one specific organ. It might appear just to be like one organ, right? In four chambers, right? The right atrium, right ventricle, left atrium, left ventricle, right? But the heart itself, right, is made of the tissue that actually make up the heart. The cells that make up the heart are different types of cells that come together to create that heart. So it is very important that we understand that it is our differences as a people that actually make us strong. So if the heart only had cardiac cells, it wouldn't be able to work. If it only had neurons, it wouldn't be able to work. If it only had connective tissue, it wouldn't be able to work. If it only had epithelial cells, it wouldn't be able to work. So the heart is like a combination of different types of cells that actually come together to give that whole function. So it's very important that when it is that we examine the physical structure, we examine it from the point of view that we are what you refer to as cellular beings. Now, when you look at the whole realms of a cell, you say, well, what he's talking about? He's talking about the cell phone. Yeah, I mean the cell phone is made up of atoms also. The cell, just like the physical structure. You as a man or you as a woman. Okay, so you might have a cell, but the cell now, which is the smallest structural and functional unit of the human anatomy, is microscopic, it's tiny, it's very small. But yet still, when you analyze that cell now is made up of, you have a cell membrane. So you have a membrane, a wall. So I won't call it a wall because the cells of the plant kingdom, right, has cell walls, which is different than the cell membranes of the animal kingdom or us, human beings, right? So when it is that you analyze that, you understand, well, look, but the cell, every single cell has a cell membrane. That means that it has a capsule that actually separates it from its environment. And yet still, that cell membrane is made up of fats, made up of proteins, right? So specifically, and still you have phospholipids, you have phosphorus, plus you have other kind of minerals that actually deal with and traverse all through the whole aspect of the membrane of that cell. So the cell now, even if it's so small, it's so tiny, it is minuscule, it still now contains what you call organelles, smaller structures inside of that cell that make up that cell. Remember, you are a human being, you big, so anybody could stay all the way down over there, they can see you, right? But I'm looking at my hands and I'm just seeing skin. I'm not really seeing the individual cells of my hand. I would need a microscope to actually enlarge it, to magnify it 100 times, 1,000 times, 10,000 times, just to be able to observe that cell that is on the skin. That's very important. So when you understand that, then you go down into the nitty-gritty of things. That's why they say that you are what you eat, So when you go down into the nitty-gritty of things, then you understand what you say, well, look, okay, then if it is that I am made of cells, but the cell is not just like one solid entity. The cell in its own cell is made up of different types of entities. For instance, as we said, the membrane of that cell is made up of proteins and also made up of fats. So they call it a phosphoprotein bilayer, right? Like phospholipid bilayer, because you have your fats, and then you have your proteins, and still you have particular types of minerals, and still glycoproteins too with glycogen, which is basically a carbohydrate. So you have different aspects, different molecules that actually make up that whole external membrane of that cell. That's very important, very, very, very important, because inside of that cell now, because it's like you're in this room and I'm in a studio right now. I mean, you might see me like this here on Instagram or YouTube, but I'm in a studio. Okay, so this is the studio. So the studio have walls, and the studio have a door, and the studio have different types of equipment inside of it. The same with the cell. So the cell has a membrane that encloses it, that actually separates it from its environment, and yet still it has different equipment, different organelles inside of it that is responsible for actually dealing with the whole realms of managing the works of that cell. All right, so okay, so the cell now, you have the cell membrane, which is like fats, and you have sugars, and you have proteins that actually separates that cell from its external environment. That is why someone with diabetes, right? Someone with diabetes might have sugar in the blood, right? So the sugar might be 150, 200, right? Of 200 milligrams or whatever in the blood. Okay, all right, so much sugar in the blood, but at the end of the day, the sugar is not in the cell. The glucose is not inside of the cell. The cell itself might be very feisty, might need the glucose to actually produce energy, because the sugar is utilized within the aerobic respiration system during respiration, whereby your physical structure would use oxygen to burn that glucose to provide you with what you call ATP, right? Which is basically your energy molecule. But because, understand that, very important, because the cell is in every essence is membraned, that means that it is separate, it is different, it is distinct from its external environment. Even if the blood has sugar, because the cell is membraned, it is actually separate. It does not really, you really won't find the sugar inside of the cell. So even if you have plenty of let's say of water outside of the studio, because my door is locked and the studio is airtight, I mean there's water outside, but I mean there's no water on the inside, or there are people on the outside, but the people really can't come into the studio because the door is closed. So for the people to come into the studio, we'd have to open the door and allow them to come in, or they have to sneak in through a crack or some kind of thing, come in through the vent and then drop down into the studio, some type of thing they would have to do. But because the cell is membraned, even if your sugar levels in the blood is high, right, it does not mean that that sugar is in your blood, is in your cells. Why? Because your cell now, it's membrane, it is enclosed. So the entities, which is called your mitochondria, that actually needs that glucose that is inside of that cell. Okay, so the cell is the smallest structural and functional unit of the human anatomy. What does that mean? The cell is microscopic. You need a microscope, an instrument that allows you to magnify tiny things, microscopic, tiny, nanometer size objects 1,000 times, 100 times, 100,000 times, just to be able to see the size of a coin, or the size of a finger, or the size of a lime or something, because you are magnifying it, you are making it bigger. All right, so the cell is microscopic, yet still it is the smallest structural and functional unit of the human anatomy. But that's not accurate, you know. That is still not accurate, because within that cell you have other structures, and even the cell, that the structure actually encloses that cell, the cell membrane, is made up of fats and proteins and sugar and minerals. So even if you have water on the outside of that cell, it won't be able to actually just go through the cell. Why? Because you have a fatty layer that's outside there protecting the inside of the cell. So even if you have a lot of glucose, sugar in your blood, that sugar is not in the cell. So definitely when somebody say, oh boy, this man have diabetes, you know, okay, so then you understand. If you don't know what the cell is and how the cell actually functions and the structure of the cell, you wouldn't really be able to understand the whole realms of diabetes. You know, so you just be dying a bit and you won't be able to actually take care of yourself. Now, when you understand that the cell is membrane, and you say, well, oh, the cell is membrane, so that means that even if you eat something with sugar, because the cell is membrane and the sugar is outside of the cell, it does not mean that that sugar could actually get into the cell. So how does that sugar get into the cell? You're right, it's just like as I was saying previously. Even if you have, I'm in a studio right now, and the studio has ceiling, it has walls, it has a door. Now, even if you have 100 people on the outside of the studio, because my door is closed, no one can enter into the studio. To allow people to enter into the studio, I have to open up the door. Okay, all right. So you understand that? Okay, all right. So then, how do things enter into the cell? So if the cell needs sugar, the cell needs oxygen, the cell needs different types of minerals, the cell needs even what you would call peptides. The cell needs plenty of different things to actually function. So how is it that things get into the cell? So for instance, like glucose, which is sugar, when it is that you eat something that contains sugar, glucose, right? Immediately the message goes into your brain. Okay, well, this thing contains a lot of sugar in. Okay, all right. Then your brain sends off a message. It sends out hormones into your bloodstream that sends down the message to your pancreas and say, pancreas, oh, there is plenty sugar in the blood. You need to produce insulin. All right, so boom. So the message, you eat the food. Okay, all right. Sugar levels go up. Your message goes to your brain. Your brain sends the message down to your pancreas. Pancreas, okay, lots of sugar in the blood. Your pancreas now tells because you have different types of cells in the pancreas, whereby you have cells that produce insulin, you have cells that produce glucagon. So the insulin allows your cell to perform, allows your physical structure to perform a particular function, and then you have the glucagon that's produced by your pancreas. It's an other hormone that allows your cells to perform a different function. And still you have pancreatic amylase, which is basically another enzyme that the pancreas also produces just to break down your carbs, just to break down your complex carbs into simple carbs, that your bloodstream could actually have the simple carbs in the form of glucose, that it could be absorbed into your bloodstream, okay, right, into your cells. Now, how does that happen? Okay, boom. So you eat something, it's rich in sugar, okay, bam, okay, your brain gets the message, okay, you have lots of sugar in your blood, that sugar needs to get into your cells. Okay, pancreas, come on, brethren, what happened to you there? There's lots of sugar in the blood. The pancreas then tells the beta cells in the pancreas, a particular types of workman cells, microscopic, very small, tiny. You need a microscope to see them, but yet still, that chemical message comes to them to tell them, yes, you have to, right now, you have to produce what you refer to as insulin. So right away, the pancreas begins to produce insulin, and the insulin now goes into the bloodstream. It goes to the cell, to the membrane. It says membrane. It fits into the key of the membrane, opens up the door, and then the glucose now could enter into the cell. So all the time that there was no insulin, even if you have sugar in your blood, it cannot enter into your cells. That's why they say you have high blood sugar levels. So your sugar levels are high in the blood, but it is not really high at all inside of the cell, because your cell is membrane. It is separate from the blood that flows through your veins, the blood that flows through your arteries. So definitely, it takes your pancreas to use that intelligence, that it gets the message from the brain, whereby it can actually tell the beta cells in the pancreas, produce insulin, and then that insulin now can open up particular channels in the membranes of your cells that allow the glucose on the outside of the cell to come inside of the cell. And then, okay, then your cells now can utilize that glucose definitely to produce energy. And then there you have it, right? But if it is that your pancreas is not involved, if there is no insulin, then you just are full of sugar in your blood. And then because you have so much sugar in your blood, right, okay, right, but you're not supposed to have so much sugar in your blood. So the kidneys now come and say, but wait, man, how there's so much sugar in the blood? Too much sugar in the blood. So the kidneys now start to filter out your excessive sugar. So you start to filter out the excess sugar, and you begin to urinate. And when you urinate now, even the urine now is sweet. That's why in Creole or French Creole, we call diabetes pisadu or sweet pea. And in ancient time, one way of testing whether or not someone had diabetes was basically to allow them to pee. So they pee on the ground, right? And then after they pee on the ground, I mean, if ants come and try and eat up or drink up the pee, what happens is that, well, look, boy, this man, they have a problem there, look, ants, they're coming to eat up all the man pee. That means that definitely this man, they has high blood sugar levels. That's what they used to do in ancient times, just to know whether or not someone has high blood sugar. They don't have no strip. I mean, you'd have the symptoms, you'd have excess first, or plenty different type of symptoms. But what they'll do, they just make you just one pee there. And if ants come, brethren, definitely, you have a problem there. Because look, it is that the ants there are fundamentally enjoying your pee because it's so filled with sugar. Now, what does that mean for the kidneys? Because the kidneys now, right, very important, because the kidneys now are so overworked, because it's not the kidney's job to actually take out the excess sugar from the blood. It's supposed to be the pancreas that produces insulin, and the insulin opens up the doors of every single one of your trillions and trillions of cells and allow that sugar to actually come inside of it. Now, because of the depletion or the lack of insulin, the sugar will stay outside of the membrane of that cell and never go into the cell. So they say you have high blood sugar levels. Now, give thanks for life and almighty that we're just blessing up our people here on Instagram. Give thanks, Melissa. Give thanks, Melanin Sovereign. Blessed Marlon. Blessed Alberto. Nico Nati. Blessed Love. Biko. Gabriel. Big Bro. Iyat Survival. Shiliato Jones. Empress Divine. KNXW47, Blessed Love, Honorable Ja Ruben, XMY Her, give thanks, Ella, give thanks. Okay, plenty of people, you really cannot tell everyone. Blessed Love, Diamond Kush, give thanks. All those people who are with us live on Instagram, definitely, we just bless you up and say, give thanks, Joe 888, give thanks, Honorable. I cannot allow you to join into this conversation right now, but definitely we give thanks for your present. Empress 6774, Sister Anaka, give thanks. Blessed Love, give thanks. So basically, what you are understanding is that your cell is microscopic. Okay, all right. That means that you need a microscope to see. All right, but even if your cell is so small, your cell is in every essence has its own internal environment that's completely different from its external environment. So anything that needs to enter into that cell has to go through a membrane, has to have a particular key, just to be able to enter into that membrane. Yes, Royal Maroons, man, so late. You're up in England and you're up so late, man. What time is England now? 9, 8, 9, 10, 11, 12. It's after 12 Royal Maroons in England, man, you're still up. Oh, my brother, give thanks for joining us anyway. Now, when it comes to the realms now, we understand that the cell is microscopic, but yet still there are so many components of that cell. So, inside of that membrane, that factory called your cell, I'm talking about a structure you need a microscope to actually see. You have to basically magnify it 1,000 times just to be able to see it. All right, so then inside of that cell, you have a nucleus, which is what you call the control center of that cell. Right now, within the nucleus, right, within that control center of that cell, you still have another organelle within the nucleus called your nucleolus, which is a dense area within that center of that cell that contains your what you call your chromosomes, your genetic material. Now, you know that scientists actually mapped the genome. So they were mapping the genome. So they were going and they mapping the genome and say, okay, when they say they map the genome, it means that they're going to take a butterfly and then they're going to bust open to get into the, remember, we are at school now. So if it is that, wise the blessed, if it is that you have to get to the nucleus of that cell, okay, let's say the nucleolus of a cell, what do you have to go through to actually get to the nucleolus? Anyone on Instagram? Come on, you could answer that. Anyone on YouTube? Are you checking the YouTube messages there right now, or are you just there standing up? Right? Anyone on YouTube or on Instagram, answer that question. What is it that you have to go through to actually get to the nucleus of the cell? Cellular bongo, right? What is it that you have to go through to get to the nucleus of the cell? Come on, answer the question. What is it that you have to go through to get to the nucleus of the cell? The control center of the cell, right? It doesn't seem like, it does seem like you were listening. Let me put the question to the people. Could you put on our telephone number? Let me see if anyone have been listening to what we're saying. Remember we were speaking initially, we said, well, if it's not the blood, I can shine, not the blood, not the, yes, Jomo 888 is the cell membrane. Yes, King activity, the membrane. But Jomo 888, have it perfectly correct, it's called the cell membrane. Okay, now, so we imagine it, we visioning this, we visualizing that. You have this membrane that encloses an entity, and within that entity, the center of that entity, you have what you would call a nucleus. And within that nucleus, you still have what you call a nucleolus, which is a dense area within the command center of the cell that contains what you call your genetic material. So for a scientist now, or any individual, to get into the genetic material, and remember, you have a nuclear membrane, so even the nucleus, the center of the cell, the control center of that cell, it still has a membrane, a nuclear membrane. So it's not like things just run in and run out of the control center of the cell. It's just like you have a building, you have a factory. Even if the factory has its external walls, but the command center of that factory is the office of the manager. Now, the office of the manager still has a door, still has its own wall, still separate. So within that factory, you'd still have different membraned portions of the factory. So you'd have where the processing zone, the packaging zone, the toilet, the energy area, and you have all different areas within that factory. So the factory have the place where you have the management. Okay, so the management takes care of, they have all the blueprints, they have all the information, they have all the information needed for this factory to actually do its work. And yet still, apart from the management, so that you still have your power plant, the people responsible to ensure that you have power in the factory. Yet still you have your line workers. So if the factory is producing CMOS icicles, so you have a whole heap of people that are producing CMOS icicles. And after the CMOS icicles are produced, the CMOS icicles are then packaged. And after they are packaged, right, they are shipped out of the factory. All right, so you have the manager of the factory contains the blueprint. The manager of the factory contains all the information about how to produce CMOS icicles. So the manager of the factory say, hey, supervisor, come here, man. Tell the line workers to begin to produce CMOS icicles. Okay, all right. So the manager now gives her the information. Oh, that's why I say, hey, brethren, tell them, man, that we need icicles produced. All right. Okay, all right. So look the instruction. Okay, bam. So the line workers now begin to produce the icicles. So then the line workers say, well, all right, man. Right now we follow the instructions. We have 5 buckets of icicles ready. Then the supervisor say, all right, you packaging staff, package them and make sure that everything is good, and put a little pinch of bladder in the CMOS icicle to actually modify it, make it last long, and squeeze a little juice of key lime in it to make it actually don't spoil. Okay, boom. So okay, you do that. Then afterwards now, you go to packaging now. So it's gonna package it, nice little, biodegradable packaging.
no kind of plastics, no parabens, no bisphenol A, none of these kind of xenoestrogens to give you breast cancer or to feminize you. Okay, all right, and boom, they say then, okay, then you get an order come from England. Yes, mate. You know how to speak in England, you know, right? Okay, so they want 100 boxes of icicles. Okay, all right. So boom. So the icicles now have to go out of the factory and be delivered through the door out into the open and goes all the way on the plane and into England. Okay, understand that? So it might seem a bit complicated, but I'm going to take you through the same process and show you exactly how your physical structure follow the same pattern, right, in the production of, okay, for insulin. Because a while ago we were speaking about the beta cells of your pancreas. Yes, world boss Dylan El Waldo, give thanks, blessed. Now, because we understand that the cell is the smallest structural and functional unit of the human anatomy, right? The smallest structural and functional unit of the anatomy. Then, so what's the function? So that cell here has a function of the producing of insulin. So we're going to say, so the insulin is going to be represented as your CMOS icicle. Okay, all right. So then the cell now has the control center, the command center. That command center is called the nucleus. Now within that command center, you have your chromosomes. You have your DNA, deoxyribonucleic acid, right? So you have that DNA that actually contains all the information on how to produce your insulin. The same way the blood cells, right, or any other cells that have a particular function, their genetic material would actually contain that information to replicate them or to actually create that material. So the nucleus in the cell gives out the information. So from the manager that gives the information, which is the nucleus, it goes out, and out of the nucleus of the cell, it goes to, let's say, your endoplasmic reticulum. And we didn't science right now. We didn't science it. Okay, so if you have a diagram of your cell, then you are learning what you call histology. So you are learning how the cells of your physical structure function. You are learning things on the microscopic level, right? The beta cells are the cells in the pancreas that actually produces insulin. All right, so then you have the cell in the membrane, and it contains a nucleus, and you have plenty different organelles in the in your cell. All right, so your nucleus say, okay, man, we need to produce insulin. All right, so if you have Google, you would Google the picture and say, okay, the cell. All right, so then your nucleus now, your DNA pass the message through RNA, messenger RNA. It's not deoxyribonucleic acid, but just now ribonucleic acid. Because your whole plant, maybe the factory producing CMOS, it produces CMOS icicles, it produces CMOS powder, CMOS capsules, CMOS gel, CMOS scrub, CMOS, all that of things. So you don't want all the information. All you need is the information to produce the icicles. So you don't want all the information from your DNA. All you want is the information to produce your insulin. So from the nucleus, the information goes from DNA into what you call RNA, ribonucleic acid, that actually goes out of the nucleus as what you call transfer RNA out of the nucleus, and then it goes to another organelle that is within your cell. I'm talking about within a microscopic structure. So the microscopic structures in that structure itself, because in your cells you have what you call organelles. You have different aspects of that cell responsible for performing particular functions. Okay, all right. So let's have some hard science there, man. Histology. Okay, we get in there. And you're scratching your head. Okay, all right. So, okay, so let's go then. So we say, all right, okay. So the message goes from the DNA. So from DNA, which is deoxyribonucleic acid, it goes into what you call messenger RNA or mRNA, which is ribonucleic acid. It takes the message and then it transfers it out of your nucleus. So it goes through the membrane, because even if the mRNA has the message, it's in the nucleus that has a membrane. So it just can't just go out. It has to go through what you call transfer RNA that takes that message to another organelle, another aspect of that cell called the endoplasmic reticulum, that actually allows it now to produce, start to manufacture the insulin. Okay, so the insulin now is being manufactured. Bam, bam, bam. I'm talking about in a microscopic cell, you know. All right? So then, because scientists understand that, you know, scientists will take that DNA and inject it into a microbe, which could be a fungi, or which could be a bacteria, right? And make that bacteria or that fungus, right? Or in the cells of a pig, right, to produce what we call human insulin. Okay, so it takes that info, because they understand how the cell actually function. They will grow and culture cells that they could insert the genetic material inside of it and make it produce insulin. And they call it human insulin, right? Produced by fungus or by bacteria, some microbe. Okay, all right. Now, so it seems difficult, but we get in there. We are getting there. It's a bit difficult, but we get in there. We have about 15 more minutes to go, and we get in there. We're gonna have a full understanding of that. So when you finish there, you can go and write your histology class and understand everything about the cells. I could have been showing you some diagrams, but bear with me, and then you could still just go on Google and then you could, you understand? Watch the video. I'm sure you understand what I'm talking about. Don't you understand what I'm talking about? All right, okay. So then from the nucleus, the message goes out from the nucleus. So from DNA to messenger RNA, so from deoxyribonucleic acid to mRNA, messenger ribonucleic acid, but it can't just go out of the membrane, because the nucleus has a membrane, so it has to go as transfer RNA. That's what you call protein synthesis. That's a very tough subject. You know. When I'm teaching you, what they call protein synthesis, a very technical subject that they teach you in histology and they teach you in physiology and biochemistry and them levels there. But I'm allowing you to understand it so then you could understand how your physical structure functions on a cellular basis. So you could understand the intricacies of the most minute aspect of your physical structure, the functions that they have to actually allow them to actually produce whatever. If it's saliva, if it's insulin, if it's testosterone, if it's estrogen, if it's progesterone, whatever it is that your cells actually produce, right? If it's sweat, right? Whatever it is, if it's sperm, whatever they produce, they have to go through that aspect, whereby messages have to go from DNA, mRNA, tRNA, then goes out into what you call your cytoplasm. And the cytoplasm is the area that is within the cell membrane, but not inside of the nucleus. So that you have this egg, right? So the egg has a shell, a hard shell on the outside. Okay? But inside of that shell, you have the egg white, and then you have the yolk. Okay, so the yolk is yellow. So the egg is really a cell. Okay? The egg is one of the biggest cells, because the yolk of the egg is basically where the genetic material is. Remember, the egg of a fowl is supposed to grow into an entire chicken, right? Okay, so imagine that the shell is the membrane, the white of the egg is the cytoplasm, and the yellow of the egg is the nucleus. So within the cytoplasm, what you have different organelles that are responsible for the production of particular substances. So in that case, for the production of your insulin, we are saying that it is produced through your endoplasmic reticulum that produce it. So just like the factory, where you have the workers producing the CMOS icicles and then saying, well, we have 5 buckets of CMOS icicles and pass it on to a different aspect of the factory so that it can be packaged. The same things happen in your cells. So after the insulin has been produced, it then goes to another organelle, another structure inside of your cell. Called what? What part of your cell? I don't know if you have any scientists here on YouTube or anywhere there. I'm going to ask the question. If you answer the question, you're going to win a book. I'm going to give you a herbal manual. What aspect of the cell, what part of the cell is responsible for packaging? Packaging and modifying. You know that? You don't remember that? This man there just finished high school and he can't even remember that. Right? No, it's not the mitochondria. The mitochondria is the organelle that is responsible for the energy production in the cell. So everything that we're talking about there is the mitochondria that produces, that gives you the energy. So your mitochondria deals with energy production in the cell. What aspect of the cell is responsible? The liver is not a cell. The liver is an organ. The liver has millions and billions of cells. Empress Delhi, yes, is the gold. It's not just the Golgi. Empress Delhi, know what she about, man. It's called the Golgi apparatus. Ask something easier, no? But look, Empress Delhi have it, the Golgi apparatus. Who said what he has in it? It's called the Golgi apparatus. So the Golgi apparatus, okay, Sister Empress Delhi, you could just send us a message in a direct mail, direct messenger, and then we'll tell you how you're gonna get your book. So Empress Delhi, I mean, you've won yourself a herbal manual. So the Golgi apparatus is then responsible for packaging the insulin into tiny packets, and then you have, from the packaging, you have what you call the shipment of it. So when your blood sugar levels rise within that cell, you already have plenty of insulin already packaged, ready to be shipped. So as your blood sugar levels go up and your brain send that message right into your bloodstream saying that, okay, pancreas, we need a lot more insulin. Bam! So it ramps up production, but you already have insulin already packaged. So definitely what it does now, it just kicks out the insulin out of the cell membrane and into your bloodstream. And then it allows your cells now to literally take in the glucose. So you see that it might look like a simple process, but every single aspect of your anatomy, you're welcome, Empress Delhi. Every single aspect of your anatomy, right, has some profound responsibilities. And the greatest thing of all is that after scientists went all the way out and they mapped the human genome, guess what they found out? Do you know what they found out? Because remember, the world is based upon division. Who believe like they better than, and who believe like they're not better than, and who believe all type of thing. So what is the difference between you and a frog? Or you and a rat? Or you and a pussycat? Right? So it is minuscule. It's, according to the Genome Project, the difference between you and a bacteria or an amoeba or a fungus is minuscule. Tiny. So much less the difference between a man and a man. And the whole world system is being run upon a better than system. Who believes like they are better than the other. And even right now you have people protesting because they say Black Lives Matter. Right? Well, they're protesting now. Right? They're protesting now about them things there, but I mean at the end of the day, it show you that all them but the scientists and them know that humanity is, everyone is organic carbon beings. Everyone is made up of cells, and there is no fundamental difference between I and I. That's why we say I and I, right? That's why, as Aki Becker would always say, and as he'd say that the emperor say, Emperor Haile Selassie, not Bob Marley, Bob Marley sang the words of Emperor Haile Selassie and says, until the philosophy that holds one race superior and another inferior is finally and permanently discredited and abandoned, there will be no peace. Okay, so when it is that people could start to see everyone, right, as equals, right, and not because of your status, or not because of your financial standings, or not because of anything, right, but until the philosophy that holds one race superior and another inferior is finally and permanently discredited and abandoned, there will be no peace. Right? So for that, the hope and the dream of lasting peace, right, will become a fleeting illusion to be pursued but never attained. Everywhere is war. That's his Imperial Majesty word. That's not Bob Marley's song, the words of his Imperial Majesty. Okay? All right. So when you hear them things there now, so science already know the truth that when they went and do the genome, they said that there's nothing that makes a man better than a man, right? As Marcus Garvey said, we are born equal, but you have to use your intelligence to become whatever that you have to become. So when we examine the whole vibe, you see, when you examine the different cells of your physical structure, when you examine everything, then you begin to understand and say, well, look, boy, look at this, man. It is really our differences that actually make us who we are. So if every cell was a beta cell, then you would have no insulin, right? If every cell was an alpha cell, right, then all you would have is glucagon, right? Because the alpha cells in the pancreas produces glucagon, and glucagon is responsible for breaking up the stored up glycogen or carbs and break it back down into glucose. So your physical structure is a mastermind, right? So for our lesson tonight, I just want all of you just to go and just look at some images of the cell, overscan the cell, and see how it is that you will actually have a better understanding of how your physical structure function. So then you understand that yes, you are a cellular being, and then every cell is still made up of carbon, because they call it organic chemistry. And every single cell, yes, Aya, blessed love, honorable, give thanks. Long time don't see and no hair from the eye. Love and prosperity, peace divine. Jah Rastafari. So when we understand that every single cell is made up of what you call atoms, that's when it gets very interesting, because remember the atom also have a nucleus. The atom have a nucleus. The atom have a nucleus, and within the nucleus of the atom, you have your proton and you have your neutron. And then so for instance, proteins are made up of different atoms, right? And the atoms, that's why you have the anatomic or the periodic table, right? So your periodic table has plenty different elements, from hydrogen to helium to carbon to phosphorus to gold to silver to mercury to lead. All these things they are different. Halogen, all these things there are different elements of the periodic table, right? So you have plenty of different elements that actually make up your periodic table and the elements that are there. Now, your anatomy, your cells, right? Even if they are so microscopic, you have to go down deeper and break the microscopic levels, even the nucleus. When you go and you get to the DNA, the DNA is deoxy. That means that it have two oxygen, ribose, that was sugar, nucleic acid. So acid it is, so it have carbon, it have oxygen, and hydrogen, COOH, right? And it's a peptide, so that has a protein, right? So at the end of the day, so it is oxygen, right? Carbon, nitrogen, phosphorus, you understand? Hydrogen, that's what actually makes up your DNA, right? So it is just elements that bind up together to actually form what you call these molecules. So when they tell you that you have your anatomy, okay, your anatomy. When they say that you have your anatomy, they say the anatomy. They are very correct because it is really the truth. It's an atom, atom, me, me. So atomy is the same as an atomy because you are really made up of elements. You are an atomic being. That's why we are electrical being, or we are beings that are actually made up of just simple atoms of the periodic table. And our consciousness, which they call black matter, right? Or they call junk DNA, because after they actually break up the human genome and thing, they found that there was lots of what they call junk DNA. That means that DNA that they don't know what it's about. That's because they are moving to in straight line, and they need to move more in a um, pyramidal, I mean, if that's a word, or a more pyramid kind of level, a more, multifaceted type of level. So at the end of the day, they call the junk DNA your consciousness, because they cannot measure consciousness. They can measure it because it has a weight, right? But they cannot measure the consciousness. So give thanks for the consciousness that lies within all of I and I, that make I and I living, man. Also give thanks definitely as our time has come to pass. I wasn't able to answer any questions this evening because at the end of the day, I just wanted to give you this high class on histology about how the cell actually function. Give thanks to all those of you on YouTube who were with us. I pray the Almighty Creator keep on blessing you. And I'm going to talk about all them other things some other time, but we give thanks for life and Almighty like you are. And definitely, as we also give thanks for our people here in St. Lucia, we could not take any calls today, right? Just because, we wanted to teach you the vibes there. So just learn the vibes and keep the vibes positive. Definitely everything would actually go positive. Remember, the Empress who actually won the book, just email us or direct messenger us, and definitely we'll be able to get that book to you. So give thanks again for all those people who are with us live on YouTube. I know that you all are watching us. So just give thanks for life and a mighty life. Give and we pray that everything works perfectly with you. So may the Almighty God keep on guiding and keeping you, and make His holy face shine upon your holy face. Give thanks for life. Cha Rastafari. Blessed. Adrian.